Okay, so now we're going to look at learning target 2. This also comes from 14.1 in your book, and that's writing a chemical reaction. And this is one of the harder ones, I think, out of the 7 learning targets. And really, it's just review, but that review is kind of built up over the last several weeks. When we talked about bonding. So we're just going to look at an example here. Again, this isn't really so much to teach you how to do it because that really requires going back a ways and looking at a lot of stuff that we did. But you'll notice I'm at chemfiesta.org, one of my favorite sites that I found. You'll notice again as you scroll down, there's a bunch of practice worksheets. And again, the nice thing about this is that he typically, or the person that puts this, I say he because his name's Ian, but he provides a lot of answers too, which is great because that's one thing I know a lot of times when you're learning something, you want to know if you're doing it right or wrong. And, so if you look at the answers, you can see right away if you're on the right track or not. So, as you look through all these practice worksheets, we've done some of these. This whole unit really is part of what's called stoichiometry. I know Angelique in 6th period kind of asked if that was a real word because I saw it on Mr. Stevick's board for his class, doing the same thing we are. And it is a word. It's a Greek word, and I can't remember what exactly that translates to from Greek, but this is kind of a big part of chemistry, and we're just kind of getting the first part of that stoichiometry. So, but we want to look at equations here. L, so let's click on that, and you'll notice that he has a couple worksheets, and I think they're pretty identical. Actually, I think just the second one adds a bit more information than the first one. And again, this extra information is a bit beyond physical science, so we're going to kind of look at this one where it's not looking at the extra stuff, but same problems though. So let's look at a couple of those, and we'll just start with the first one here. Maybe some of you already looked at these, but one thing that you want to think about as you're going through these is when you look at the reactants and products is trying to figure out if they're ionic or covalent, because that's really going to determine how we write these things. And then another consideration again is, do we have any of the 7 elements that are in that acronym Hofbrinkel? Because if we have any of those 7 elements, then of course we want to remember that it's going to be O2. And you'll see that in number 2 here. So I'll kind of skip down number 2 first, but it says when isopropanol, and that's C3H8O, burns in oxygen, carbon dioxide and water and heat are produced. So hopefully, you guys are starting to get some of this stuff down. Again, one thing I wanted to point out is that you can see here that we've got a reactant, oxygen, and so there's nothing with oxygen. It's just oxygen, so it's going to be O2 when we write the formula for oxygen. And one thing you might also notice now is that the products are carbon dioxide and water, and those are 2 clues, along with oxygen as a reactant, that we have combustion here. So we're not talking about types of reactions yet, but now that you've kind of gotten that part, you might start to identify what types these are. So we've got combustion here. Of course, another clue to combustion is that it's exothermic, and the fact that they told us that heat is a product is also, again, another clue that it's exothermic, because exothermic reactions release energy from the system to the surroundings. Okay, anyway, kind of a sidetrack there, but I wanted to kind of mention again the Hofbrinkel part with oxygen. So let's go back to 1. We have dissolved beryllium chloride reacts with dissolved silver nitrate in water. So again, some of this is just extra words. I'm trying not to worry about some of these extra things like dissolved. However, if you're curious, dissolved in water, aqueous, all those things are saying the same thing, which is that these 2 reactants are aqueous. This product is aqueous, and then another product is silver chloride, it's a powder, so actually we've got a solid there. And when you see these reactions, you'll see what's called a precipitate. You'll actually see when you pour these two liquids together, you'll get some kind of cloudy formation, and that cloudy formation is actually a solid that won't dissolve in the liquid. So that's why you see the cloud, because it's actually precipitating out of the solution. So anyway, all that stuff I just said is kind of extra information. I'm not really testing you on translating that into the states that they're in. I'm really more concerned with, can you recognize, or can you actually write these words into the formulas that the reactants and products are, because this really just gets to speaking the language of chemistry. And some of you may lament that, but everything has its own language, no matter what you're interested in. Whether it's skateboarding or whether it's surfing or whether it's poetry or whatever. I mean, everything has its own language. So really, this is what Learning Target 2 comes down to, is just really getting more familiar with the language of chemistry. And part of that is translating words into formula, and vice versa, formula into words. So let's go ahead and finally do this. So we've got beryllium chloride. If you look at the periodic table, you'll see that beryllium and chlorine, which is what chloride comes from, they're on opposite sides of the periodic table. So hopefully you guys are starting to realize that, hey, I've got a couple things going on here. Number one, I've got a metal and a non-metal. They're also very far apart on the periodic table. And so let me just pause it here and I'll pull up an interactive periodic table so you can see that. Okay, so I went ahead and pulled up that interactive periodic table we've looked at before. And you can see again, we've got beryllium way over here in group 2. And we've got chlorine way over here in group 17. And again, just like we said, they're far apart. It's ionic. So that's kind of the point that I'm trying to make. Because it's ionic, we have to think about beryllium and chlorine as ions, because that's going to determine the correct formula. So, a lot of times when people are just trying to guess, they might be saying, oh, I've got beryllium chloride, that's going to be BeCl. That's the formula. But when you look at the periodic table, you'll kind of notice that beryllium in group 2 has 2 valence electrons. It's going to lose those 2 valence electrons and become a positive 2 ion. Whereas chlorine has 7 valence electrons, wants to gain 1 more to get the same configuration as argon. So chlorine is going to gain 1 electron and become a negative 1 charged ion. So we have a positive 2 charged ion, a negative 1 charged ion, plus 2 and negative 1 don't add to 0. So we actually are going to need 2 chlorine atoms to balance the charge of 1 beryllium ion. So again, 2 chlorine ions to balance the charge of 1 beryllium ion. So it's actually going to be BeCl2. That's going to be the correct formula. And again, the first question you want to ask yourself is this going to be ionic or covalent? Next one's silver nitrate. Again, silver is a little tricky. If I threw that at you, I would tell you that silver typically forms a positive 1 ion. So again, we've got an ionic compound once again for a couple reasons. We've got silver, which is a metal. And one thing I'm noticing on the stuff that I'm seeing from you guys is that some people say, well, you've got nitrate, which is a nonmetal. Well, you'll notice nitrate is not actually on the periodic table. Nitrate is NO3, so it's a polyatomic ion. So you'd be right to say that it's ionic compound because we've got a polyatomic ion. But you can't say that nitrate's a nonmetal because it's not even on the periodic table. So don't think of polyatomics in terms of metal or nonmetal. Just think of elements themselves as metal or nonmetal. So again, we've got a metal silver. We've got a polyatomic ion nitrate. So, for a couple of reasons, we've got an ionic compound again. Silver is, again, a positive 1 charged ion. nitrate's a -1 charged ion. Those do add to 0. So the formula for silver nitrate is just going to be one of each. Silver, Ag, nitrate, NO3. So AgNO3 is our second reactant. Now for the products, and again, you might start to notice here as you write these out, this is going to be a double displacement reaction. We have in this first two reactants A, B, C, D. So for our products, we're going to get A and D. And you'll notice A beryllium and D nitrate do give us beryllium nitrate. So we've got beryllium again. These are going to be all ionic compounds here. Beryllium is a +2 ion, like we said. Nitrate's a -1 ion. And so we're going to need 2 nitrates. Remember, for polyatomics, if you need more than one, we need parentheses to show that. So it's going to be Be parentheses NO3 close parentheses 2. And then the last one we have is silver chloride. That, remember, is Cb. So the order does matter. I noticed in the last quiz some people switch that around. But remember that for ionic compounds, it's always listed the positive ion first, followed by the negative ion. That's why it's Cb, because C in this case is our positive ion, so our cation. So it's cation followed by anion, always for ionic compounds. Silver again is +1. Chlorine is -1, +1, -1, they add a 0. So this last product is AgCl. Okay, so now let's look at the answer. We have beryllium chloride, BeCl2, plus silver nitrate, AgNO3, and that's going to, then we're going to have an arrow, and that's going to produce or yield beryllium nitrate, Be parentheses NO3 close parentheses 2 plus AgCl. So again, if you went through this on your own, you want to see if you did it right, you can go down there, and then you can see that we do have those reactants and products: BeCl2, AgNO3, Be parentheses NO3 close parentheses 2, AgCl. And again, you see the extra information behind each of those reactants and products: aqueous, 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 and solid. AgCl, silver chloride, is our precipitate. But that's just extra information. One thing you will need to do, however, and you notice that they did it here, is once you finish all that work, you will need to balance these. And so to balance this, and in order to conserve mass, we need 2 of these compounds, silver nitrate, and 2 silver chlorides. So again, the coefficients going from left to right is going to be 1, 2, 1, 2. And that makes everything work out. So that's just an example of learning target 2. Again, that is going to be a hard one for some people because it really goes back quite a few weeks on learning how to do a lot of different things. So just be patient if you're still struggling with it. Again, I know some of you might get frustrated because this takes a long time, but that's just the way it is. Sometimes some people take a while to catch on to things, and some people catch on right away. But it doesn't mean that you're not capable. So just keep practicing, and I have confidence that eventually, with enough practice and effort, and doing it the right way, of course, then you can figure out how to do it. So on to learning target 3.